In this video, we're going to discuss kinetic energy. The objective in this is that students will be able to identify the components of kinetic energy and how work and kinetic energy are related. So get out your notes and something to write with, and let's get started. Remember, you can pause the video anytime you wish to listen back to any slide again. So let's start off with what kinetic actually means. According to Merriam-Webster, a kinetic means of or relating to the motion of material bodies and the forces and energy associated therewith. So in other words, kinetic energy means energy due to an object's motion. The equation for kinetic energy, as written on the AP equation sheet, is K equals 1/2 mv squared. The K meaning kinetic energy, measured in joules, just like work. The M standing for mass, measured in kilograms. And V standing for velocity, just like it always has, measured in meters per second. In case you didn't notice, kinetic energy and work have the same units, which are joules. This is not a coincidence. To do work on an object is to change its energy. Like a car's brakes. If you slam on the brakes are doing work to slow the car down, so it's changing its kinetic energy, it's decreasing it. If you press on the gas pedal of your car, you're having the engine do work to increase the kinetic energy of the car and make it speed up. An airbag slows you down, so it does work to bring you to a stop in an accident. So all these things are examples of things doing work to change the amount of energy in a moving object. So work and energy are very much related. More on work and kinetic energy. So this equation here, the change in E equals work, is actually on the equation sheet, and it literally means that the change in energy is equal to the work done. So if the brakes on the car were to do work to stop the car, then its kinetic energy would decrease as a result of that work. Or you could do work to increase the energy using the accelerometer, just like I already said in the previous slide. So the change can be a positive change or a negative change depending on if the kinetic energy is increasing or decreasing. Time for a challenge question. So let's say a car is traveling with some speed v with some amount of kinetic energy k. If the car's velocity is doubled so that it's equal to 2 times v, what happens to the kinetic energy of the car? Is it A, the same amount of kinetic energy, B, half the kinetic energy, C, twice the kinetic energy, or D, 4 times the kinetic energy? If you said D, you would be correct, because since the velocity is squared in the equation, then doubling that actually quadruples the kinetic energy. You have to square that factor as well, so 2 squared is 4. Time for the second challenge question. Let's say a car of mass m is traveling at some speed v with some amount of kinetic energy k. If the car's mass is doubled so that it is equal to twice the mass, what happens to the kinetic energy of the car now? If you said 4k just like the previous one, then you would be incorrect. It's actually twice the kinetic energy. This happens because since mass is not squared in the equation, doubling the mass just doubles the kinetic energy. That's a direct proportionality. Thanks for watching. As always, make sure to take the Edmodo quiz online to receive credit for the notes, and bring your notes with you to class to help with the note quiz. If you have any questions, feel free to message me on Edmodo. Thanks for watching.